Everyone to the Geo Aqua Watch webinar. This is the most exciting final webinar in our 2025-26 webinars series season. And we will start again with webinars around September, October. We already have a couple expressing interest. We're just trying to set dates with them, but we have plenty of room for others. So if anybody out there in the audience is interested in presenting aquatic remote sensing webinar, about an hour and recorded, if you don't mind, that would be great. Just send me an email. I will put my email in the chat. We are recording today's webinar, and we also want to remind everybody in the audience, except for the speakers, to mute their microphones. You can certainly use the chat to ask your questions. Sometimes my questions just fly in and out of my head, so it helps me to just type them right there in the chat, and we will moderate them at the end, moderate the questions, or at the end, you can come off mute and ask your question directly out loud. So with that, I'm going to go ahead and introduce our speakers. We have three speakers today. Dulcinea Avouris. In her research, she uses aquatic remote sensing and model development and testing, and also change detection using multispectral and hyperspectral imagery from a variety of sensors and platforms. She earned a bachelor's in geology and master's in geophysics from Michigan Technological University, and her doctorate in applied geology and remote sensing from Kent State University. She previously worked at the University of California, Merced, the USGS California Water Science Center, and is now employed by Hazen and Sawyer, an international water resources consulting company developing and distributing remote sensing products for water utilities. The second speaker will be Dr. Samantha Sharp. She is a water resource engineer by training and an expert in aquatic remote sensing. Samantha earned her undergraduate degree from the University of California, Berkeley, in civil and environmental engineering, and then worked for several years as a professional engineer in both the public and private sectors before returning to graduate school. Samantha earned her master's and PhD degrees from the University of California, Davis in water resource engineering, supported by a NASA graduate student fellowship. Her graduate research focused on understanding algal blooms in lakes using remote sensing methods. And Samantha is currently a NASA postdoctoral program fellow at NASA Ames Research Center, advancing the application of novel remote sensing technologies and techniques for managing inland water quality. Our final speaker will be Dr. Fernanda Maciel. Her background is in hydraulics and environmental engineering. She was a Fulbright Scholar for her Master of Science degree at the University of Illinois at Urbana-Champaign here in the United States. And then she earned her PhD degree from Universidad de la República from Uruguay in Latin America, where she has been an associate professor since 2023. Fernanda uses a multidisciplinary approach to environmental monitoring using optical techniques, including remote sensing for water quality applications in inland and coastal waters, especially sediment-rich waters. And let me admit a couple people here who were out in the waiting room. And for those who just joined, sorry you missed the introduction, but you can refer to the website. At this point, I would like to turn the conversation over to Dr. Dulcinea Avouris.
Hi, everybody. Please let me know if my sound kicks out, and I will get louder and probably closer to my camera. But so Sam and Fernanda and I are going to be talking about a review paper that we wrote that came out of a workshop. So we're calling this Addressing Aquatic Remote Sensing Validation Gaps from Discussion to Application, a 4-year journey. Next slide, Sam. So a little bit of a background on the workshop that we participated in. It was held in Madison, Wisconsin, at the University of Wisconsin back in 2022. And this workshop was designed to bring together remote sensing experts from the international community. It was led by Dr. Stephen Greb, who at UW, University of Wisconsin-Madison, and Dr. Colleen Mao at the University of Rhode Island. And there were about 70 of us, I think, who gathered, not just from the US, but from multiple other countries as well. And the workshop was designed to be really just sort of a discussion. So we talked about things like gaps in data that were measured at inland and coastal waters that are needed for remote sensing model development. We talked about variability in the quality of those field measurements. We talked about the pros and cons of field measurements versus laboratory-based measurements. And we also spent some time talking about barriers to entry for remote sensing generally, and particularly for scientists who are outside the United States and Europe. And then as a group, we established the deliverables for this workshop, which were a review paper, and then additionally a website with resources. So also just to give you a glimpse into the review paper process for us, we ended up with 27 co-authors out of that group of scientists at the workshop, which was phenomenal, a really big range of expertise and knowledge. The 3 of us at the time were early career scientists, and most of our co-authors were expert senior scientists. So it was a learning process for us. It was really, actually, I think, incredibly positive. We got a lot of good guidance from all of these experts, but they were very gracious in just following our lead for this paper, which was wonderful. So just again, briefly, the 3 of us outlined this paper. We divided it into sections, and each of us took one of the section. Then we talked to the participants in the workshop to see who wanted to contribute and who wanted, in what section they wanted to work on. As we all do now, we used a Teams account and Google Docs and more emails than I can count to coordinate. Ended up iterating quite a bit on the text and the figures for each section. And then we had to bring the paper into alignment with US federal guidelines for science publications, because we had folks from the USGS, EPA, NASA, NOAA, as well as the European Space Agency who were contributing to this effort. So all of that took a couple of years. And then we had a couple of rejections from the journals before it landed in a place where we were able to publish. So we are very happy that that process is done and that this paper is out for everyone to be able to refer to. The background in the paper itself that I'm going to talk about is a section we called State of the Science. And this was just sort of presenting 4 fundamental elements of aquatic remote sensing, like where are we today? Talking about mission capability, those are the satellite missions, talking about model development and how we've moved in many ways from statistical or arithmetic relationships between remote sensing, spectral data, and field measurements into using more machine learning based model frameworks. We talked about sort of the state of the science for in situ observations, the instruments that are available, how they've developed, and then we also talked about operational capacity. All of this information, and this is where the resource website comes into play, is available on the GeoAquaWatch website. Much of it is available in the validation section. And Sam, if you want to switch to that real quick, we're just going to point out where you can find this. So this is the GeoAquaWatch website. They have a validation tab here. There's information about each of these categories, in situ measurements, what they are, plus references, remote sensing reflectance, again, background information. So everybody who comes here is on the same, knowledge page. And then for IOP measurements, and then AOP measurements and water quality measurements, we provide some information about what they measure, but then also a table that describes the types of measurements, the examples of some of the sensors that are available on the market, and then the pros and cons of each type of sensor. And this was one of the aspects of our workshop where there was a lot of discussion about field sensors versus lab sensors, which ones were good, which ones were not so good. And so we wanted to make sure that we categorize that in a way that was really helpful.
Sorry, should I go back to the presentation now?
Yes, please, Sam. All right, and now actually I'm handing it over to you.
Okay, great. Now I'm going to go through the next kind of section of the paper, which was talking about validation gaps, and then providing some recommendations that we kind of like came to from this workshop. So I reordered this just a little bit from how the paper was structured, just for how I thought it made sense to talk about it now. So first, looking at validation gaps, we kind of talked a lot about the adaptation of open ocean protocols for inland and coastal waters, and how these are kind of a lot of the protocols we have available to us, but they're not always the most appropriate. For example, inland and coastal waters are highly dynamic systems. And so it's really important to choose an appropriate sampling time window. And we really need near coincident sampling times with satellite overpasses to have good quality data for validation. These systems have high spatial variability. So this is important when considering spatial aggregation of data, and also for considering appropriate spatial scales for sampling. Inland and coastal waters are challenged in terms of atmospheric correction. And traditional atmospheric correction models used for the open ocean aren't always appropriate for inland and coastal waters. And then there's some other factors that need to be considered as well, including adjacency effects, that they are optically shallow waters, and that you have to account for mixed and contaminated pixels as well. And finally, inland and coastal waters are case 2 waters. So as opposed to open ocean, which is a case 1 water. And so for that reason, it's important to sample all 3 major optically active constituents, including chlorophyll A, suspended particulate matter, and CDOM. So next, looking at validation gaps for apparent optical properties, or AOPs. In general, the biggest observation and issue we found with this topic is that there's just really a lack of remote sensing reflectance validation data for inland and coastal waters. And so that's a big need for this area of work. But in order to get more remote sensing validation data for inland and coastal waters, we need protocols that are relevant to inland and coastal waters. And along with those protocols, we need trainings and tutorials to really teach people how to collect these measurements appropriately. Additionally, we identified a need for systematic uncertainty budget calculations so that we're all kind of accounting for uncertainties in a similar way, so that these data sets can be used together in an appropriate manner. There's a need for easy field calibration checks to make sure that sensors are capturing accurate data. And we also recommend recording ancillary data with measurements so that when these measurements are put into databases, we have all of that data consistent and useful for other researchers. And finally, there's a need for more research into known issues. Some of these I've mentioned already, but adjacency effects, impacts of shading, and reflectance from deployment platforms and sun glint, for some examples. So next, validation gaps for inherent optical properties, or IOPs. We identified a need for in situ sensors for measuring absorption and scattering that are designed for highly attenuating and scattering mediums, such as are found in inland and coastal waters. And in the absence of sensors that are designed specifically for these conditions, there are adaptations that we recommend following. For example, appropriate flow tube lengths and scattering corrections should be used for AC meters, and a serial dilution approach and pathway correction should be followed for backscattering BB meters. We identified that further study is needed into the effects of particle size, composition of dissolved and particulate matter, and algal community composition and pigments on inherent optical properties. We recommend deployment of several instruments in order to complete appropriate correction procedures of those measurements. And finally, we recommend comparing modeled remote sensing reflectance, which can be modeled from IOP measurements and using radiative transfer modeling, with the measured remote sensing reflectance as sort of a closure experiment to make sure that your measurements are accurate for IOPs. Next, validation gaps for water quality parameters. We recommend that validation occur across a range of conditions and seasons. We recommend that methodological information is reported for uncertainty characterization. We recommend that standard protocols be followed. For example, replicants should be collected to make sure that your lab analysis of these parameters are accurate. We recommend protocols and hands-on training be produced for these different water quality parameter measurement procedures. And finally, we identified that there's guidance that's really needed for dealing with different interferences. For example, non-photochemical quenching, which impact these field measurements. And additionally, guidance should be produced for site-specific calibration of instruments such as fluorometers. Next, for our validation gaps, we looked at a bibliometric review to really identify where research is being completed and like where there are gaps in this research. So we did this bibliometric review using the Elsevier Scopus database search, which was through May 21st, 2025. And to do this search, we used these keywords that were searched in the titles, abstracts, and keywords of studies for remote sensing, water quality, including Secchi depth, disk depth, water clarity, chlorophyll A, and other similar terms, lake, reservoir, river, estuary, delta, coastal, or inland to really specify the sites we're looking at, and then validation or evaluation. And I kind of learned through this process that I need to be better with selecting keywords for my own studies, just to make sure that my own work is found through these studies. So the results of our bibliometric review, we found 611 studies have been published since 1986 on this topic, inland and coastal water remote sensing validation. And there's been a significant increase in the past years, which you can see in this plot here. And these studies have been completed primarily in the United States and China. You can see from this plot here that 48.2% of these studies were based in the United States and China, but overall 55 countries are not shown here that have less than 6 studies each, with these 20 countries comprising the majority of studies at 82%. So there's definitely kind of like a geographic discrepancy between where this research is happening globally. And you can see that, so first here, we also identified that there are gaps in the parameters in these studies. So overall, there's a lack of inland and coastal water remote sensing reflectance data in many databases. For example, the LIMNATES database has only 8.2% of its data is remote sensing reflectance. So that was kind of identified as a gap from existing water quality databases for inland and coastal waters. And then geographically, there's an overall lack of inland and coastal water data from the global south, especially in Latin America, the Caribbean, Africa, and also in boreal high northern latitudes. And you can see in these figures from the paper, these are the distribution of data from the Gloria database, inland and coastal water data specifically for aquatic remote sensing validation, and then the distribution of data in the sea-bass database, which is primarily ocean data sets. Finally, there are validation gaps for user engagement. There are currently few training opportunities available for collecting this type of validation data, and those trainings are only available in English. So we recommend that protocols should really, there should be training opportunities available in other languages, but also protocols should be translated to other languages as well to make this information more widely available to hopefully identify or manage some of the geographic gaps in these validation data sets. Additionally, there should be more work towards building end user trust of remote sensing data for aquatic targets. And some areas that we identified to kind of build this end user trust are to produce analysis ready products, to publish user success stories to really show where this data can be useful in applications. And that products should be co-developed and co-produced with end users throughout the process. Finally, there's a need for low-cost sensors to expand these global validation data sets. And this figure here from a recent manuscript shows an example of one of these low-cost sensors for measuring remote sensing reflectance. So key recommendations from the paper are we identified that there needs to be increased validation studies in understudied regions. There's a need for validation education resources that are multilingual and written for experts as well as non-experts. There's a need for protocols for validation in inland and coastal waters. There's a need for better communication of uncertainties and expectations with remote sensing products. And this is for both field measurements as well as satellite data products. And finally, further research on specific validation issues for inland and coastal waters, which I've talked about earlier. There's a lot more details on these recommendations and additional specific research opportunities that we identified that you can read about in the manuscript, as well as the supplemental materials to the manuscript. And then also on the GeoAquaWatch website, we have these summarized at this link here. All right, now I'm gonna pass this over to Fernanda.
Hi, everyone. Thanks, Sam. So what I'm going to talk about is not in the paper, but I think it's a nice case to close this presentation because it aligns, this application case aligns very well with many of the paper's recommendations. So I'm going to talk a little bit about a workshop that was held in Montevideo, Uruguay in last February of this year. And it was a workshop on the evaluation of chlorophyll A products for Latin America and the Caribbean. It was organized by Remarco, and I'll just talk in a minute about what Remarco means, and funded by the International Atomic Energy Agency. And that's the name of the project. And we had participants from many Latin American and countries and the Caribbean countries, such as Colombia, Uruguay, Mexico, Argentina, Chile, and Cuba, and Panama. I think, yeah, those were the participants that were physically present here in Uruguay, but also we had other participants that were online. And also we had experts from Japan, Mexico, and the US that helped us with the workshop. And can you go to the next slide? Okay. So this workshop was organized by Remarco, and Remarco is the research network of marine coastal stressors in Latin America and the Caribbean. And it works in several areas, such as chemical pollution, microplastic pollution, harmful algal blooms, and ocean acidification, and the topic that brought us together for this workshop, which is eutrophication. And eutrophication in Latin America and the Caribbean, similarly to other regions in the world, it has been identified as a problem in many countries due mainly to anthropogenic pressures, and it's also worsened by climate change. But at least here in the region, it's often understudied, it's often unquantified, and it's also part of the United Nations Environmental Program Sustainable Development Goals that many of the countries, if not all, in Latin America and the Caribbean, have committed to adopt. And there is this specific sustainable SDG, Sustainable Development Goal, number 14, which is life below water, that is to conserve and sustainably use the oceans, seas, and marine resources for sustainable development. And within this objective, there is the need for prevent and significantly reduce marine pollution of all kinds, particularly from land-based activities, and including marine debris and nutrient pollution. And here's where eutrophication comes. So one of the indicators that the countries have committed to report to the United Nations is the index of coastal eutrophication. And of course, this is very resource intensive and time intensive if we want to report this indicator based on field measurements. So here's where the potential of satellite remote sensing comes in, and because with satellites we could estimate chlorophyll A, and from chlorophyll A we could estimate at least the potential eutrophication from the coastal and marine areas. And I'm mentioning here a couple of papers that have done this in other parts of the world, like Brando in Europe and Terauchi in Asia. And okay, but these two examples, oh, sorry, can we go back? These two examples occurred after years of local or regional developments, including recalibrations of chlorophyll A algorithms, both in Europe and in Asia. So this was ultimately the motivation for this workshop, because there was no validation of chlorophyll A satellite products for Latin America and the Caribbean, at least not in a way that covered most of the countries. And so the motivation behind this was that good science and validation should be behind the report of this indicator. Now, yes, can you go to the next one, Sam? So the objectives of the workshop were to evaluate satellite chlorophyll algorithms and products to determine which are the best suited for the complexity and diversity of coastal areas in Latin America and the Caribbean. And we wanted to work directly with national data from different countries to test and eventually calibrate these products. And finally, to adopt the most effective products and methodologies for each area of interest and create a standardized protocol to guide the reliable use of satellite information for estimating chlorophyll A in Latin America and the Caribbean. And with the workshop, we achieved objectives 1 and 2. And objective 3, we're still working on it. It's an ongoing and future work. So we want, as I said, a science-based indicator of potential eutrophication, and and report report an indicator that is based on regionally validated chlorophyll A estimations. Can you go to the next one, Sam? Okay, so this figure is very small on purpose because it was not the objective of this presentation to show the results of the workshop. I think that it deserves its own webinar. So I'm not going to talk about these results, and because it's also an ongoing work. This is just an example of one satellite product that we tested for the region and for with the data of all different countries. But I want to highlight that we followed several of the recommendations, or we aligned with several of the recommendations of the review paper that we wrote and that Dulce and Sam summarized. We prioritize quality versus quantity. We prioritize spectrophotometry or in situ fluorometry, but that was calibrated for local conditions. So we had site-specific calibrations or calibrations within a field campaign, but we did not use like the manufacturer's calibration of the fluorometers. And we prioritize spectrophotometry over fluorometry. We also selected statistical metrics recommended by the paper, but we made sure that they made sense for our ultimate objective of quantifying potential eutrophication. So we needed sensitivity to chlorophyll A, and we did not need exact precision, right? An exact prediction of chlorophyll A, but we need the satellite products to be sensitive to chlorophyll A variations. It was also we also considered atmospheric corrections that were specific for case 2 complex waters, as many coastal regions in Latin America and the Caribbean. And it was a collaborative work that gave us the possibility of integrating for the first time, and this is important, regional validation exercises with data provided by several countries in the region. Next, please. So to close the presentation, I just wanted to highlight some of the how the workshop aligned with the paper recommendations, because we plan to develop a protocol that it's going to be in Spanish, probably both in Spanish and English. But I think this one was one of the main things that we talked about in the workshop, and also in the review paper, the need for materials and guidance manuals in other languages other than just English. It is a validation exercise in an understudied region. It integrated national expertise and international support. So we gather, I think this is important as well, because we gather national experts on remote sensing from Latin America and the Caribbean, and we also had support from Japan and the US, but we are not using a product that works well in other part of the world. We are using our local knowledge to make sure that it works for this region. And we're also trying to target regional and user needs by considering the complexity and diversity of coastal areas and regarding satellite spatial resolutions. So like some regions like parts of the coast of Chile or Mexico, we cannot use ocean satellites. We can only use, for example, Sentinel-2 or Landsat because of the spatial resolution. Also water optical complexity, and here we have regions, for example, in Uruguay and Argentina, that we have tons of suspended sediments, and we cannot use any chlorophyll A product because it wouldn't work. So we have a need for different algorithms and products depending on the region. And also, and this is also, it was also very important, the sustainability of applying the methodologies in the future. So we want the methods to work well, but we also want them to be easy to apply. So so they can be effectively used by the countries for reporting the potential eutrophication indicator. And I think this is it. As I mentioned, I want to thank you all the participants of this workshop that allow me to show part of this experience. And I think it deserves, I also told Mary Beth that it deserves its own webinar when the work is done. And I think, yeah, this is the last slide. Here we go. So I want to thank all of you for listening to our presentation, and we are happy to answer any questions with Dulce and Sam.
Great job, as everybody is using their reaction emojis and finding their unmute buttons. I did just want to say, absolutely, we will schedule a Remarco or a workshop, a webinar outlining the workshop report whenever they're ready. Thank you, ladies, so much for your presentation today, too. I did want to ask, do you think, just because I happen to have something come across my desk recently, by the way, if you want to ask a question, go ahead and unmute and use the raise hand button. But I had an opportunity come across my desk for using virtual reality and for repeated exercises. It's useful, and I wonder if maybe leveraging that might be helpful. Of course, it doesn't get over the language thing, but yeah, so like best practices in the field and then in the laboratory.
Oh, do you mean use virtual reality to provide an interactive experience for learning how to use instruments? Or...
Yes. Yeah. So somebody could film it. You can have different scenarios. I guess a lot like how the kids dissect frogs these days, where they just put on glasses and they experience, they don't actually dissect a frog. It's like a pretend frog.
I guess my kids are grown up enough that they haven't done that. That's fascinating.
Yeah.
Personally, I think that it still needs to be balanced with some hands-on. I think that would be a great way to really, similar to, it would give you one step beyond like a video showing you how to set something up. But you still have to put your hands on the instrument and make sure that the hookups are right, and But yeah, interesting.
Okay. So anybody want to ask a question of any of our three speakers? Dulcie went first, then Samantha, and then Fernanda. Is it time? I'll ask another one. Is it time for another validation workshop? Like a repeat of when was the first one? Was it 2022?
The first one I think is 2012, right? And then yeah, Colleen's paper was from 2015, and then we had another one 10 years later in 2022. But I don't know. There is
a couple more.
Sorry.
I was just gonna say maybe a couple more years and then do it again, especially when we're still digesting the information. On the other hand, things are evolving rapidly, particularly in model development. Sensors obviously and satellite missions take an enormous amount of time to, design and build and launch, and are subject to the vagaries of the political climate. But model development and being able to use data in different ways and perhaps, sort of helping us better understand exactly where the qualitative versus quantitative level lies for different approaches to modeling. That's certainly a topic that needs to continue to be discussed and discussed broadly within the context of, capabilities in different areas of the world.
Yeah, I personally think that, yes, Lucy said things evolve very rapidly, and like as we go on, like there are many studies that are using satellite data for modeling or for different study or to analyze trends or different studies, and I think it's kind of healthy to remember from time to time that if there is not an appropriate validation of the products behind those studies or the use of that type of data, the final results will not be so trustful. So it's and I think like everything is kind of evolving together, but I think that, yeah, these gaps that we mentioned are still still valid.
Great.
I have a question for both the speakers in the group. I've been watching more from the sidelines, but getting really interested in what's happening with PACE. And some of the early results are really exciting. Having that much hyperspectral resolution is and rapid returns is really giving us a new possibility. But with that comes, as we globalize this, are there global algorithms? Do we need to be regional? Or is there somewhere in between? It looks like machine learning and some other modelings put together with PACE are helping that. I can't get into details, but one of the graduate students on a committee of it and just gave results for TSM in globally, and it's been iterative, but at this point they're getting quite close to something that could be a global algorithm, and that for TSM that's remarkable.
I'm going to jump in first. Sorry, Sam and Fernanda. This is actually something, that kind of model, or this sort of interplay between global models versus regional models is something that I've thought a lot about in the last few years. And in my opinion, I think that as we are better able to leverage machine learning frameworks for those different retrieval models, that we can get closer to what we would think of as a global model, because those frameworks can be more flexible in terms of integrating in a chlorophyll model, for example, the impact of TSM, turbidity, whatever, you know, category you want to, whatever measurement of that, that optical indicator you want to call it, you know, but between increasing spectral information from hyperspectral sensors, and we would really love one with a much but between more spectral information and then models that are able to take into account all of the different you know, sort of sometimes conflicting spectral signals, that we could apply one model framework for chlorophyll and have it be able to work in different places, because the framework itself is flexible within the space of how chlorophyll and TSM are often conflicting signals. Does that make sense? So I think the answer to that is that it ends up being almost a hybrid, right? Where you have a model framework that gets deployed, but it works in different areas because that model can account for, again, for example, with chlorophyll, variability in TSM or turbidity. But I don't think we're quite at the point where we have, because PACE is phenomenal, but that PACE doesn't work for inland and coastal waters because the footprint is so large, right? And so like we're getting there.
Yeah, and also another thing with PACE is that it doesn't have yet an atmospheric correction that works well for complex coastal waters, right? So, and I think that's still a barrier with some satellites for coastal waters and inland as well, because we have large reservoirs or very large lakes that could use PACE. But I personally believe that gap is going to be filled soon. And then from that, we could have, like, as Dulce said, an algorithm that could work globally, taking into account, especially for turbidity, that is not as complicated as chlorophyll A, for example.
Any other questions? I'm not able to see. Does somebody unmute? Okay, let me ask one other question. Just because it was asked, I happen to be on a call with the IOCCG yesterday, their scientific committee, and they asked me what interest does private industry have in doing some of these? Like, some countries are even wanting to take over or to transfer their satellite programs to industry, so that the government is no longer collecting that data. So I just wonder, not putting you on the spot, Dulcie, but you are working for one of those companies. So I wondered, would your company be interested and able, if given the money, I mean, presumably if the funding went away from the agency, that would go to the private industry, is there a market to do the validation collection as well as the quality control for the data? And then anybody else who wants to answer that question.
So I will say that there is a massive interest in remote sensing data for water quality by public utilities, in my experience so far in the US. you know, they're very interested in using remote sensing to monitor for harmful algal blooms in their reservoirs, to identify where the hotspots are, to guide field measurements, to help provide data for beach closures, because some of the reservoirs are also managed for recreation, like all of those integrated things. I think that it fundamentally comes down to capacity. And I think that, you know, that ultimately comes down to funding, right? So with funding, many things are possible. I have pretty strong opinions about public versus private satellite data. But if we're staying in the realm of field measurements and sampling, and then having that data be available widely, that's probably a discussion that could be had amongst, you know, companies like mine, which is a consulting company for water utilities, you know, but also like just public utilities. Many of the utilities that I've interacted with do their own sampling in their reservoirs, and that data is not publicly available. Sometimes it is, you know, and so there seems to be, it's kind of a hodgepodge of what you can get, what you can't get, who's doing what sampling, what instruments are they using. But most public utilities are very interested in making sure that their water is in good shape, because ultimately it costs them less for treatment if they're, you know, if their reservoirs are better quality, and if the ecosystem is working properly. So I don't know if that really answers your question, but it's kind of a maybe. I think so.
So Dulce's for like a value added, still agency collected open source data, but then a value added opportunity for industry.
Yeah.
Okay. Samantha or Fernanda, any opinions? Might be dicey for you, Samantha.
Yeah, I mean, I feel like it's a really complicated issue, that there's like a lot of potentially exciting things happening in the private sector with satellite development right now. But again, like going back to what Dulce was saying, yeah, my biggest concern is just like making sure the data is freely available. That comes, I mean, it like becomes challenging when that, you know, these private companies, they have to recoup their costs somehow. And so like, what is the like financial model for that? But then like having this data available as well. So yeah, this is a good question for a general discussion, because it's, you know, kind of a complicated one with not a clear answer.
Okay, great. Any other comments or questions? All right. I did just want to point out, since we mentioned more validation is needed in the fall, we don't quite have a date scheduled yet, but another webinar presenter will be presenting validation in the Baltic Sea, throughout the Baltic Sea. Dr. Delin Jiang from the University of Stirling is going to give that presentation. So we hope you'll come back for that and many other GeoAquaWatch webinars. I am seeing there is one question. Oh, not a question. Love the recommendation about a protocol in Spanish. It is much needed. From Alba Guzman Morales. Yeah. So second that. Yeah. So a reminder again, today's webinar is recorded. It'll take me until probably tomorrow before I can get it up on the website, but the link is available. I think I've pinned it in the GeoAquaWatch website. We also do encourage you to go to the GeoAquaWatch website, plunk around on all those links under the resources tab. that they showed us, that they made available, and are thoughtfully curated for you, because it might save you some time to get right to the recommended stuff, and instead of just doing a Google search and having to sort through all that nonsense sometimes. So let's pause for another round of applause for our presenters today. And we thank you so much for coming to the last GeoAqua Watch webinar of the season. We hope you'll come back again in September. And if you want to volunteer for a webinar, shoot me an email and we'll see if we can work towards more inclusive training opportunities as well. So
Thank you for having us.
of course.
Thank you, Mary Beth, and thank you, everyone.
Yeah, thanks everyone for coming.
Have a great day.